We've already discussed how to eliminate a variable by multiplying one of the equations, but I think we're going to do a quick review of that. I'm just going to do maybe 3 or 4 examples, and then that way you have something that you can look back on and practice with. I'm just going to dive right in. So we're going to do example 1. And example 1 is going to be 3x plus 2y equals negative 13. And 3x plus 4y equals 1. All right, now the first thing you want to look for is the same coefficient, opposite signs. So if I look at my x's, I have the same coefficient, 3's, but I do not have the opposite signs. If I go to my y coefficients, those are both different. I have a 4 and I have a 2. So I want to go back now and look at my x coefficients. Since they're both 3, I want to make one of those a negative 3. So I am going to multiply one of the equations by negative 1. So I think I'm going to go ahead and multiply the first one by negative 1. So that's going to give me negative 3x minus 2y equals positive 13. Just take the other one and bring it over. Positive 3x plus, whoops, that's a plus 4y equals 1. Okay, so these are now going to cancel each other out. We have 4 plus 2, negative 2 is going to be 2y equals 14. Divide both sides by 2. And y is equal to 7. Now y is equal to 7. Come over right away and put that in your ordered pair as y, not x. So I'm going to substitute. I'm going to use my second equation. So 3x, substitute, 3x plus 4y equals 1. Y is 7, so that's going to be 4 times 7. So 3x plus 28 equals 1. Subtract 28 from both sides. 3x equals negative 27. Divide by 3, divide by 3, x equals negative 9. Okay, so this first equations, the first systems that we worked on, you're going to multiply by a negative 1. Okay, so always look at your coefficients for each variable to see what you would need to multiply by. All right, second example, we have 6x plus y equals 15. Negative 7x minus 2y equals negative 10. All right, so I'm going to look at my x coefficients, my variable x. Those are different coefficients. They do have opposite signs, but they're different coefficients. So if I get to my y's, I also have a negative 2 for a coefficient. So here I don't have the same coefficients, but I do have opposite signs. And it would be really easy to eliminate that y if I multiplied my first equation by a positive 2. So I'm going to get 12x plus 2y equals 30. Keep the other one, negative 7x minus 2y equals negative 10. So now I've canceled those two out. So I have 12 minus 7, which is going to be 5x, equals 30 plus negative 10, which is 20. Divide both by 5. X equals 4. So I'm going to come over and put 4 right away into my parentheses. I'm going to choose my first equation, the original. So that's 6x plus y equals 15. I'm going to multiply my x, so 6 times 4 plus y equals 15. 6 times 4 is 24, plus y equals 15. Subtract 24 from both sides. Y equals negative 9. Okay? So we multiplied one equation. The first example, we multiplied by -1. And the second example, we multiplied by 2. All right. Let's go to our third example. Okay, we have 5x plus 3y equals -4. Negative 9x minus 12y equals 27. Okay, so I'm looking at my x-coordinates. I have 5 and -9. Now I do have opposite signs, but there's nothing I can multiply by 5 to get me 9. Okay, so I'm going to go to my y's. So I have 3 and -12. So I have opposite signs. Is there anything that I can multiply by 3 to get 12? Yes, I can multiply it by 4. So I'm going to multiply my first equation by 4. So I'm going to get 20x plus 12y equals 16. I'm just going to bring my other equation over. Negative 9x minus 12y equals 27. Negative 16. All right, so I'm going to draw my line, add them. They cancel each other out. I end up with 11x equals 11. Divide both sides. X equals 1. Substitute. I'll use my first equation. 5x plus 3y equals -4. 5 times 1. So that would be 5 plus 3y equals -4. Subtract 5 from both sides. 3y equals -9. Divide by 3, divide by 3, y equals -3. All right, now those are the ones you're going to be multiplying. Now let's remember there are two special cases, and I seem to think you guys are forgetting that you need to have a number on both sides of the equal sign. There can be absolutely no variables. So if you have a variable that says 3x equals 0, you still need to divide by 3 on both sides. But I'm going to do those special two cases for you one more time. All right, so we're going to have example 4. We have 4x minus 8y equals 10. Negative 2x plus 4y equals 15. So if I look at my first coefficients with x, I have opposite signs, but I'd have to multiply the second equation by 2 in order to eliminate the x. Here for the y's, I also have opposite signs, but I would have to multiply my second equation by 2 in order to eliminate that. So I'm going to go ahead and multiply my second equation by 2. So my first equation is going to stay the same. My second equation is going to become negative 4x plus 8y equals 30. Now when I add these two together, the x's disappear and the y's disappear. So what's left on that side of my equal sign? A 0. And 10 plus 30 is 40. Will 0 ever equal 40? No. Therefore, this is no solution. Okay, there's no variables left there. I only have values. All right, the last one, if I have negative 14x plus 6y equals 24. Negative 7x plus 3y equals 12. So if I look here, I have negative 14 and negative 7. Well, I could multiply by 2 and I would have 14, but I'd have to multiply by negative 2 because I want this to become a positive 14. If I go here, I have 3 and 6. I can multiply 3 by 2 to get 6, but it has to be the opposite sign, so I have to multiply that by negative 2. So the first one's going to stay, negative 14x plus 6y equals 24. Now my next one, I'm going to multiply negative 7 times negative 2. That becomes a positive 14x. 3 times negative 2 is negative 6y. And 12 times negative 2 is negative 24. They would have to be all opposites. They cancel out, and you get 0. 24 plus negative 24, 0. This is now infinitely many solutions.